In this video, we will introduce the graph display featured in BluelightAI Cobalt. Cobalt uses methods from topological data analysis, or TDA, to build graphs representing your data. In constructing these TDA graphs, the goal is to capture, compress, and display the shape of a dataset. This is done by clustering the data based on the local proximity of data points to one another, and then linking those clusters based on their proximity to one another, and repeating this process multiple times to create a hierarchical set of graphs of increasing coarseness. Cobalt makes this hierarchy of graphs easily navigable, as we will see here in a moment. Let's walk through an example of a TDA graph constructed by Cobalt. For this example, we're using the wine quality dataset, which is available from the UCI machine learning repository. This dataset consists of about 6,500 wines, red and white, with 11 continuous features that capture different physicochemical properties, such as density, pH, residual sugar, and so on. For this example, we have standardized the data to have zero mean and unit variance. Nodes in the graph represent clusters of data points, and edges between the nodes indicate proximity or similarity between clusters. We are using the Euclidean distance as our metric, but Cobalt supports many other metrics as well. The size of the nodes gives a relative indication of the number of data points represented by each node. At the top left are two sliders, coarseness and connectivity. Coarseness controls how much local detail is preserved in the TDA graph. Increasing this gives a more coarse representation with more data points grouped into fewer nodes. Connectivity controls how similar two clusters need to be in order to be linked by an edge. Increasing this will allow edges to be drawn between clusters that are less similar to one another. And decreasing this will allow edges to be drawn only between clusters that are more similar to one another, reducing the total number of edges drawn in the graph. An important tool for navigating these graphs is the ability to color by any feature of our choice. One of the first colorings that one might apply is a coloring based on the target variable or ground truth label present in the dataset. In this case, the target is called quality, which is a subjective score ranging from 0 to 10. Coloring the graph by quality, we see that wines in these lower regions of the graph tend to be rated more highly than the other wines. We also know that our dataset has a categorical label, which is the color of the wine. If we color the graph by that label, the wine color, we now see that the two large groups in the graph contain the red and white wines, with red here at the left and white wines in this group at the right. Let's color the graph by density. Here we see clusters of denser wines in these locations of the graph, and we notice that white wines have a greater range in density than the red wines do. Let's color by residual sugar. We see that there are some white wines with considerably higher levels of residual sugar than any of the other wines in the entire dataset. Another key feature when using Cobalt's TDA graphs is the ability to create and compare groups. Here we have collapsed the graph view so that we can better see the data groups section without having to scroll. The graph is once again colored by the wine's quality rating. And we've used this Create Groups button to create two new groups, high rating red wines and low rating reds. We can select one of the groups, this is the high rating red group, and compare it with any other group that we've saved, as well as all of the data or the rest of the data. Let's compare against the low rating red group. Then we get a statistics table that shows us significant differences between those two groups that we're comparing. For example, volatile acidity seems to be considerably lower in the high rating reds. Citric acid is higher, and so on. Let's go ahead and color by volatile acidity. Sure enough, in the high rating reds group, the volatile acidity is lower than in the lower rated reds. If we color by citric acid, we see that indeed it is higher in the higher rated red wines and lower in the lower rated red wines. For this particular analysis, we're working prior to any sort of trained machine learning model. If we did have a trained machine learning model, we could take its embeddings and predictions, performance metrics, incorporate those into Cobalt, and quickly identify any groups in the data on which the model is not performing well. To summarize, TDA graphs let us see shape and structure that's present in our data. Coloring the graph lets us understand how different features vary within the dataset by highlighting that variation directly across the graph structure. And group comparisons let us quantify differences between any groups of interest. Combined, these tools provide a solid foundation for making the most of BluelightAI Cobalt. And there are many more features available. Check the documentation for more information and stay tuned for future videos. Thanks for watching.